Standard 12 Chemistry, Unit 12, Aldehyde, Ketone and Carboxylic acid, Part 6. Today we are going to learn about the chemical reaction of aldehyde and ketone. Aldehyde and ketone both possesses carbonyl group, and because of this their chemical reactions are similar. Here the aldehyde and ketone, they both possesses carbonyl group. Carbonyl group of the carbon is electron deficient and it possesses partial positive charge, and carbonyl group of the oxygen has two lone pair of electron and having partial negative charge. Between carbon and oxygen, double bond, one is sigma bond and second will be pi bond. In nucleophilic addition reaction, pi bond will break and the new atom is introduced. Here in the chemical reaction of aldehyde and ketone, we will discuss about the nucleophilic addition reaction, and number 2, the nucleophilic addition and nucleophilic addition elimination reactions like addition of hydrogen cyanide, addition of sodium bisulfite NaHSO3, addition of Grignard reagent, and addition of alcohol. First of all, let's see about the nucleophilic addition reaction. The reaction is carried out into two steps and its mechanism. In first step, the reaction is slow. Here the carbonyl group of the carbon, partial positive charge, and the oxygen having two lone pair of electron and partial negative charge. Nucleophile will attack either on upper side of the or lower side on the carbon atom of the carbonyl group. Is slow reacts step. It is reversible reaction. First step, this nucleophile will attack on the carbon and it is attached here. That means here it is a group, alkyl group or any other atom, same as B, and this oxygen now having three lone pair of electron and partial negative charge, and tetrahedral intermediate is formed. which is very unstable, and the bond angle between A and B is 109 degree and 28 minute. Second step is fast step. And the proton transfer. Nucleophile atom or group A and B, and now this will be OH, and the addition product is formed, which is stable. And here this carbon is carbonyl group of the carbon is sp2 hybridized, and it is changes to sp3 hybridized carbon. Now the addition of hydrogen cyanide, sodium bisulfite, Grignard reagent, and the alcohol. Here first of all, let's see about the electrophile and nucleophile. For HCN, H and Cl, so H will be act as electrophile and cyanide will act as nucleophile, is the first case. And the second case, sodium bisulfite NaHSO3, sodium bisulfite Na plus will act as electrophile and the SO3H will act as nucleophile. Number 3, alkyl magnesium halide or this Grignard reagent. Here R or alkyl, which is act as nucleophile, and the MgX, that is electrophile. And number 4 is alcohol ROH, or here alkyl, which is nucleophile, and the here alkoxy group is nucleophile and the hydrogen will be electrophile. So here first of all, let's see about the nucleophilic addition reaction. Addition of hydrogen cyanide, carbonyl group, it possesses carbon partial positive charge, and here oxygen having 2 lone pair of electron and negative charge. Hydrogen cyanide in CN will be act as nucleophile. which will be attack on the carbon atom of the carbonyl group. The double bond will convert to lone pair of electron, and here is carbon. Now oxygen, here double bond will convert to single bond, and oxygen having 3 lone pair of electron and negative charge, and this Cn will be attached with the carbon Cn. This slow reaction or slow step. H plus proton transfer, and the hydrogen H plus will attach with the oxygen OH, and the product is formed, is known as cyanohydrin. Here carbonyl group of the carbon, it is either aldehyde or ketone. For example, H and Ca3, it is acetaldehyde or ethanol. Hydrogen cyanide is added to the acetaldehyde. Cn will be act as nucleophile, which is attack on the carbon. So carbon has positive charge and oxygen having negative charge, and here this double bond will convert to single bond, and oxygen is 3 lone pair of electron and negative charge, and here Cn is attached, and this will be same Ca3 and hydrogen. In second step, proton transfer. This will be attached with the oxygen Ca3 H, here OH and Cn. So it is named as acetaldehyde cyanohydride. Acetaldehyde cyanohydrin. And the another reaction, when acid act as catalyst, carbonyl group of the carbon having positive charge and negative charge of the oxygen H plus, this will be converted to lone pair of electron, and here is carbon, this will be converted to single bond and oxygen. Now this hydrogen H plus will attach with the oxygen, and the carbon possesses positive charge, and the CN or cyanide is formed. The first secondary step is very fast, and it is converted to OH, and CN will be attached with the positively charged carbon. CN is cyanohydrin. When base is used, hydrogen cyanide react with hydroxide is H2O, and Cn minus is formed, which is nucleophile. So here the preference is given to the base carbonyl group. Cn is, which is nucleophile. This nucleophile will attack on carbon. This oxygen having 3 lone pair of electron and negative charge, H plus transfer. This will be attached with the oxygen, and it forms cyanohydrin. So here this cyanide Cn minus, carbon and nitrogen both are nucleophile. Is ethanol, which will react with hydrogen cyanide, carbon, and here CH3, which will be same here. It possesses partial positive charge, negative charge, oxygen, and 2 lone pair of electron. This cyanide will attack on the carbon, and it is converted oxygen. This double bond will convert to single bond, and having 3 lone pair of electron and negative charge. Now this carbon is chiral carbon because there are 4 groups or atoms are different. It is chiral carbon. It is named as ethanol cyanohydrin. proton transfer. This H plus will attach with the oxygen CH3 CH will be same, and here OH, and this cyanide is converted to COOH. Okay, here in hydrolysis it is named as lactic acid, or its name is CH3CH OH or COOH 1 2 3 2 hydroxy propanoic acid. Here this carbon is chiral carbon. Ethanol to lactic acid. Number 2 ketone CH3 is acetone, hydrogen cyanide HCN, positive charge, and here negative charge. In first step cyanohydrin is formed. Methyl CH3 remains as it is, and this double bond will convert to single bond, and oxygen having 3 lone pair of electron and negative charge. This CN will be nucleophile, and which is attack on carbon, and its name will be acetone cyanohydrin. Which is further hydrolysis or H plus transfer. This will be remains as it is, CH3, and here H plus will be attached with the oxygen and OH, and this cyanide will convert to COOH. Now it's simplify with CH, OH, CH3, COOH, 1 2 3. Its name will be 2 hydroxy 2 methyl propanoic acid. Okay friends, so these two reactions is very most important. In first step, acetone react with hydrogen cyanide and it forms acetone cyanohydrin. In second step, hydrolysis process is carried out and H plus will be transferred, and it forms 2 hydroxy 2 methyl propanoic acid, or here the another conversion from ethanol to lactic acid, or its IUPAC name is 2 hydroxy propanoic acid. Okay friends, so next time we will discuss addition of sodium bisulfite. Thank you very much.